Hi, thanks for sharing your time with me today. I'm excited to be here with everyone virtually for Clojure North. I grew up in Toronto but never had a chance to work in the city. I'm looking forward to connecting with folks out there innovating on my favorite tool of the trade. Today, I'm here to talk to you about debugging production issues under stress. I'm lucky to have lived through a few startups built on Clojure. Going strong at 4 years, Motiva has been the longest surviving company that I've been involved in since day one. Our first production issue was one of the most stressful for me. We were 4 months in, my first time responsible for an enterprise product. I witnessed for the first time the excruciating effort it takes to sign up an enterprise user. That first user actually came from our CEO, Dave's personal network. But still, he had to have calls with the directors, presentations with middle managers, and demos with the analysts until they finally agreed to give us a try. So 1 month into the pilot, the customer was on the support line with Dave. Picture this scenario: 6 people on the customer side with your CEO, something wasn't working from their pilot, and they want answers. So Dave called me on his other line, and I ended up having to debug and review the instance on the spot. That was 4 years ago, so I don't actually remember what happened, but I do remember the anxiety and panic having to debug a production issue while our customer was waiting. There was so much wrong with that situation. The biggest problem being why we need our customer to discover the issue before I realize that there's a problem. Things do fail and are expected to fail, but as long as it doesn't impact your customer, then you're fine. That was not the case here. We had a series of production problems after release. I felt the pressure of imposter syndrome when the system didn't work. I kept thinking to myself, when am I going to get fired? Am I good enough for this? But more importantly, I felt that I've let my team down. Dave was my mentor for a previous startup, so I jumped at the chance to work with him and his team. I was in East Africa at the time when he asked me to join Motiva. A month later, I was back in San Francisco, so I felt that I had a lot to prove. Things are a lot better nowadays in so many ways, but I still mess up occasionally. Just last month, there was a production issue requiring updating about 200 records, but I was careless and accidentally changed 25,000 records instead. You would think that after 4 years of keeping the system humming, I would know better. Enough with my stories for now. For this talk, I'm going to review the debugging process on a high level, dive into a practical example, and then discuss ways to be more effective debugging production issues under stress. On a high level, there are 3 steps to debugging. First is figuring out what happened. Conceptually, you have your known system and then something unexpected happened. And now, what you know about your system isn't entirely true anymore. The process of debugging is to identify this unknown and mentally apply that to your knowledge about your system to gain a new understanding. I find this image here useful because it simplistically illustrates the debugging process as an arrow. With the right tools and techniques, you can maximize the known or minimize the unknown. But if you yourself is not in the right mindset, then it's difficult to make this flow of combining knowns with unknowns happen. Step 2 is to act on your new understanding to bring your system back to a normal state quickly. You want to do this as soon as possible to minimize impact to your customer. And then, after the immediate threat is over, you can take the time to improve your system so that this doesn't happen again. It's important to do step 3 so that you close a learning feedback loop. These are lessons from real-world usage, so you don't want to dismiss them. Let's take a look at a recent example. This incident happened last month. Our engineer noticed that one of our work queues is backed up and that some jobs have been delayed substantially. The first question to answer on a production issue is, what is the impact of this problem? This turned out to be a catastrophic failure that was affecting all of our customers. An hour later, I was called and hopped on our Slack channel immediately. Notice the timestamp. Our team and customers are in North America, but I currently live in Japan. This incident happened in the afternoon for my team, but it was 2 in the morning for me. I usually freshen myself up, do some jumping jacks, and then get right on it. For this case, it took about 10 minutes to diagnose the problem, another 10 minutes to come up with a hot fix, and then I spent the entire next day to patch a permanent fix. This was a high-impact but easy case. But overall, we are much more efficient at bringing our system back online than ever. Allow me to go into a bit more details with my diagnostic process. After doing my jumping jacks, I usually go through 5 steps to figure out and fix a problem. For this incident, we know that the send batch queue was backing up. We know the severity of the situation was critical as all customers were affected. That immediately scoped our investigation down to A, the send batch subsystem, and B, at a layer that's wide-ranging. The first gives us a hint at which part of the workflow, and the second gives us a hint on which level of stack we should be looking at. A caveat to this guessing is that you are seeing the symptoms of a problem. Our send batch queue was backing up. That's probably because the send batch worker was getting delayed. But why was it delayed? That could be caused by something happening in the send batch worker, or it could be something else entirely. As you might know, cascading failures are common because one unexpected behavior can lead to another. So always keep an open mind and double-check your assumptions in the process. At this point, I have formed my first suspicion on which direction to look. It's time to look for clues. I start from the first place of evidence. The queue was backing up, so I look at the metrics on this queue. How many messages were sent to it in the past few hours, and how many messages were received. The clue finding goes on until I have a good idea on what happened. The problem here turned out to be a new database query that took way longer than expected. So I read the query in the repo to reproduce the problem for validation. Anyway, the rest of the steps are pretty self-explanatory. One thing that you'll notice is that I use the repo a lot in this process. While doing research for this talk, I found a number of talks on debugging with Clojure from this very conference. Dana is giving a talk on using the Clojure repo, Wesley is doing a workshop on fighting production fires with the repo, and James talked about fixing bugs from other people's code last year. So I'm going to refer you to their talks and move on to our next section. We talked about why debugging is stressful, so what can you do about it? For the remainder of this talk, I'd like to share some of my personal coping strategies that worked for me. Remember the story about our first production fail? I was experiencing imposter syndrome and felt that I was letting my team down. Soon afterward, Dave said this to me. When something fails, it is not one person's problem. It is the team's problem. I didn't have an epiphany or anything. Life went on. We had problems popping up well into our second year, and even to this day. But what changed at the moment is that I heard it loud and clear that my team's got my back. During every incident, there wasn't any finger pointing or shaming. Each major incident is followed by a post-mortem review, very matter-of-factly identifying what went wrong, what was the impact, and what can we all do better. And it's not just engineering. We ask questions like, how can we improve communication with the customer to set expectation? Can we improve the user interface to guide users to more desirable behaviors? And what can the rest of the team do to support engineering during an emergency? Over time, my perspective on production problems have flipped. I now see production issues as an essential path of feedback to the system and to my team's learning. As I mentioned earlier, you build a system based on what you know and expect. Production issues are unknown that you may have missed. We learn from them and move on. Nowadays, we actually start off new hires with debugging and customer support work. But changing your perspective is easier said than done. It's like saying, oh, you're burnt out, don't be burnt out. Or, oh, you're depressed, don't be depressed. A practical and well-known approach to handling an emergency effectively is getting prepared. I came across this story recently from Daniel Coy's book, Culture Code. Back in 2011, on the night that the US Navy SEAL team captured bin Laden, one of the two helicopters carrying the team crash-landed on arrival. The second helicopter, which was supposed to land on the rooftop of the main compound, had to veer off to land outside. But as we all know, the mission was ultimately a success. How did the team know how to handle that emergency? The satellite image on the left shows a CIA training facility in North Carolina. The picture on the right shows bin Laden's compound in Pakistan. For many weeks before the mission, the team had trained for all kinds of failure scenarios. Helicopter crashes outside the compound, inside the compound, on the roof, in the yard, hundreds of yards away. Partway through each of these exercises, their commander would surprise the team with the order, "You're going down now." The pilots would auto-rotate the helicopters to the ground, and the team would then attack the mock compound from wherever they happened to be. After each exercise, they would review what went wrong, owned their mistakes, and talked about how they might do better. In our field, one of the most famous examples of this notion of practicing for failure is probably the work at Netflix on chaos engineering. One of their first released tools, also from 2011, called Chaos Monkey, randomly disabled computers in Netflix production network to test how remaining systems respond to the outage. For us as Motiva with limited resources, we sometimes do failure mode and effect analysis, basically a mental exercise to identify weak points in our design and listing what we're doing about them on a spreadsheet. In the Clojure community, we talk about hammock-driven development, giving time to think. At the very least, as part of our development process, we spend some time to think about what are the failure modes and impact to what we're doing. Speaking of post-mortem review, we record our debugging step by step as we go about debugging production issues. In the beginning, this was a way to generate training material for our new hire, but since then, we found other uses for it. For one, writing out the steps acts as rubber ducking during the troubleshooting process. Secondly, if we need to come back the next day or later to make a longer-term patch, we have recorded precisely what we need in exploring this problem. Lastly, we are building a repertoire of debugging knowledge within the company that's easily searchable. Which brings us to the next point. One of our engineers, Chao Wu, started a debugging playbook. This is a collection of hints and actions for reference during an emergency. We have architectural diagrams, state diagrams, activity diagrams to serve as maps for navigating and scoping down an issue. We also list out where to find what. A good thing to do is associating business logic with database table names. Otherwise, it's not obvious that the table Run Experiment Journal is actually useful in diagnosing sandbatch worker issues. Stepping back, as Rich Hickey have said, simplicity is a prerequisite for reliability. We're still working on that, but in the meantime, having a playbook and maps to our system alleviates confusion. In addition to diagrams and words, we keep a collection of diagnostic functions in a REPL namespace. For each of our programs, we have a REPL namespace with a collection of often used diagnostic functions. This namespace is checked in with the rest of the application code and gets deployed to our production. My colleague, Jonathan Irving, started this habit. Besides the fact that it's useful to keep our place as executable chunks of code, we're using code instead of making ad hoc changes, reduce human errors. Remember earlier I mentioned that I messed up a hotfix and changed 25,000 records instead of 200? Well, I was being lazy and actually edited our production database directly. One idea that I'd like to explore, but haven't gotten around to it, is to use JUPYTER Notebook for debugging. Imagine the interactiveness of a REPL with the power of record keeping and replays for use with diagnosis. Before I move on to the next bit, let's talk about something higher level. I'd like to bring your attention to one of my favorite diagramming tools. For the longest time, I was looking for a low-maintenance way to illustrate high-level views of our system. But the biggest issue with documentation is that they go out of date. It's even worse for diagrams because I'm not going to be bothered with moving an arrow or adding a box every time we make changes to our code base. So I want diagrams, but I don't want to draw them. The obvious choice is some sort of text-to-diagram tool. The second question, how do you represent your business logic, architecture, control flow, and all these different perspectives to your system? This is probably obvious to some of you, but I actually tried a few random things before serendipitously rediscovering UML, Unified Modeling Language. I had completely forgotten about them since university. UML, as the name suggests, is a modeling language to visualize the design of a software system. You might remember them as class diagrams when learning an object-oriented language, but they cover much more aspects of software design than that. On the screen here to the right is a state diagram showing one of the behaviors of our system. After trying a handful of text-to-UML tools, Plant UML hit the right balance for me. It does everything that I want and their syntax is straightforward. The left image shows part of the syntax to generate the state diagram on the right. We version control these Plant UML code and generated diagrams alongside our source code. We talked about preparing yourself and your team for emergencies. Now let's talk about preparing your system to make debugging easier. Along each of the steps of debugging, there are some things that you can do to make your life easier. Actually, there are many things that you can do, but I'll go over just a couple that we find offer good efforts to benefits ratio from our experience. The case for continuous deployment is well analyzed and discussed with the popularity of agile development. In the context of how it might help you with debugging under stress, this fits with the idea of maximizing knowns and minimizing unknowns. In my previous example, I debugged an issue in 10 minutes and fixed it in another 10 minutes. That's partly because we just deployed to production several hours ago. We know the problem was affecting all customers, so something new probably happened. I had a quick look at our Git history and saw that we made changes to a section that the clues point to. For the hot fix, I didn't have to patch the problem on the spot. All I had to do was to roll back the service to a version a few hours before. And because it was very recent, there wasn't any incompatibility to resolve with the rest of the system. It's difficult to have to roll back and make sure that the older version of your program works with the current latest version of the rest of your system. That's a whole DevOps topic altogether. But we do find that keeping a clean Git history goes a long way. It's much easier to have a clean Git history with a straightforward path to branch off and cherry pick. Along the line of scoping down your debugging search space, your program's versions act as a time axis variation. The way you divide your program is another axis. In Motiva's case, we have well-defined business lifecycles to our workflow. Here's the state machine diagram to our campaign lifecycle. Earlier when send batch queue failed, I know immediately that it's a particular worker relating to our running campaign lifecycle. You can actually see the arrow labeled send batch on this diagram. We structure our code base and architecture according to our lifecycles, basically domain-driven design, so that things are where we would expect, such that knowing where in the business process the system failed would instinctively narrow the scope of our diagnosis. This is an obvious but important one. First of all, if you haven't done so already, make use of a logging library and integrate with the incident notification service. Like everyone else, we use Clojure's tool start logging macro in our programs. all of our logs are captured to a log search engine. Warnings and above are pushed to Sentry for management and Slack for visibility. Errors, specifically, are pushed to OpsGenie, which will text and call whoever's on support duty immediately. There are so many incident monitoring services out there, and integration is generally easy. You can probably get everything set up in less than a day. In the beginning, we rationally categorize errors as an error level if it's unrecoverable and warning level if it's recoverable. But that turned out to be a bad choice because if an error is unrecoverable already, then there's not much to do about it. Nowadays, we categorize error level as user impacting, time critical, and fixable issues, and warning level for issues that also are user impacting, but they might not be time critical, or might not be fixable. Hypothetically, if I really want to optimize for the team's stress level, why not delay all incident responses to business hours? Aside from the obvious impact to customers, I'd rather get woken up at 3 a.m. and fix a problem quickly, instead of waiting until the next day and let the problem snowball itself into a bigger headache. Surfacing the right amount of errors and routing them to your team for responsiveness is a balancing act. You don't want too much to stress out your team, but you don't want too little to let problems affect your customers. Suppose you are now routing your errors appropriately, but then you get this message in the middle of the night. Activate campaign, quote-unquote some ID, bad request. Unless I know what to do already, that message is confusing. I still need to spend time to figure out the context and then figure out what to do. Be specific and spell out actions to take in your error messages. When something fails, I want to know what failed, how it failed, why it failed, and most of all, how to fix it. Say that in your error message to save yourself some stress. If you're capturing and printing appropriate messages already, the next step is to actually implement error handling for automatic recovery. The best way to sleep through the night when you're on support duty is if your system can resolve problems itself. Designing for failures is a broad topic. Luckily, Clojure North has you covered again. Check out these talks when you have a chance. On the other end of the stack, clean code goes a long way. When your code and architecture is pretty much what you expect, it makes your life a lot easier when debugging and figuring out things under stress. Wouldn't it be a breeze to debug a simple system as Rich Hickey has defined in his talk, Simple Made Easy? Another reference that I enjoy is Robert C. Martin, Uncle Bob's Clean Code, one of my favorite books on programming in practice. Writing clean code and building simple systems are areas that I'm still learning. Before moving to my concluding slide, if you want more on debugging under stress, I can recommend this trilogy of talks from one of my favorite technical speakers. That was a long way to say practice good software engineering. My colleague sent me this graph illustrating percentage of defects introduced versus life cycle of development. Most problems are introduced in the coding stage, and the cost to repair problems is much cheaper early on. This coincides with our experience at Motiva. Early on, we were moving fast to iterate on the product, at the expense of quality. Many of our problems at the time were bugs that I introduced. Those problems took many hours to fix. Whereas now, we're adamant about clean code for clear communication, taking more time understanding a problem before thinking of a solution, and generally documenting as much as feasible. Like I talked about using UML diagrams. I'm a big fan of them now, but the last time I used UML was back in university almost 20 years ago. In many ways, I feel like I've gone full circle and going back to the basics. As developers, bugs are a fact of our lives, and debugging is stressful. But it's up to you on how that might affect your well-being. There's currently so much going on in the world already. I hope that this talk has been helpful to you in some small way in this difficult time. So eat your vegetables, exercise, and don't let the bugs bite. Thank you for your time.